So let's quickly spend a second here. Okay, so our plan is to basically consider the Lu decomposition, right? So what that is that Lu decomposition is this property that for a given matrix with appropriate conditions, you can rewrite this matrix as L times U, where L is a lower triangular matrix and U is an upper triangular matrix. You guys with me on that? This is probably not particularly surprising if you think about the way elimination works, right? Like, if I think about what they're kind of pantomiming here, they're saying, like, look, A is a lower rectangular matrix, or a lower triangular matrix already, right? And so if I wanted to rewrite this as a lower triangular matrix times an upper triangular matrix, I could rewrite it as my lower triangular matrix just times the identity matrix. And the identity matrix, you would note, is diagonal, right? But diagonal matrices are upper triangular. So they're basically saying, look, dude, you're done here. Like, if it's already lower triangular, then the upper triangular matrix in the decomposition is just the identity matrix. But then they're saying, all right, so, like, look, you really should figure out what the kind of L is here. And the way you're going to figure out what L is you're going to think about how this actually goes normally. So the usual process for this is you start with A, right? And then you consider, all right, so I'm going to take A and I'm going to start multiplying by some elimination matrices, right? You guys kind of with me on that? So as I multiply by those elimination matrices, these guys, right? I'm going to have this kind of case where I'm going to end up with EI's multiplied together times A is going to give me the identity matrix. Then these guys here, the product of all of these, is going to be a lower triangular matrix, and that's going to be the inverse of that is going to be the L in my... Sorry, yeah. So the inverse of those guys is going to be my lower triangular matrix. And in this case, those inverses multiplied together are probably going to give me A again. Well, they're going to give me A inverse. Does that make sense? If I lost you guys completely here.
I'm following.
You with me, Cody?
That makes sense. Yeah.
Okay, so our plan is first to just find the elimination matrices, right? So the E21 matrix is the first one that I want to look at for this. So I'm looking at this matrix A, and I'm thinking, all right, so what am I going to need for E21? Well, E21 should be targeting this A here. That's going to be what I target with E21. So let's see.
I'm kind of mixed up because...
Go ahead again.
I have a different A in the front in my question.
Am I in the wrong section?
Ask, is this the right thing? I've been looking all over. I can't find where you got this.
I'm in 2.6, problem 8. Yeah. Is that not what's in the print copy of the textbook? Oh, shit. Oh, that's funny. I don't have a software copy of this. Apparently the software copy is just slightly different. I wonder if this is the software copy the fourth edition? No, it says it's the 5th edition. Huh. That's super weird. Yeah, the scanned copy is a little different. Well, that's obnoxious. Okay, well, let's solve the problem that we were actually supposed to then. Let me just do that and do this.